That's good. So now we can share that with Valerie and Eleanor. So guys, I think that I'd like to see you guys draw a rectangle. And Stella, can I see you draw a rectangle as well? I don't know what you're doing right now. So I'd like you to turn to the camera so we can see you draw a rectangle. And the idea is that Mom made a bowl of dumplings. And so the rectangle represents all of the dumplings. Now, first, Lynn ate half the dumplings. And so what we can do is let's cut the rectangle in half, and let's even make like a little perimeter around that rectangle, because that represents 1/2 of all the dumplings. Now, another person, Hua, ate half of the dumplings remaining. Oh. Jason, do you have a question, buddy? Raise your hand, honey, if you have a question. That would be great. So anyway, guys, Hua ate half the dumplings remaining. So what should I draw inside the blue rectangle? What do you think? Catherine, Stella, Jason, do you have any ideas about that? What I could draw inside the blue rectangle to represent what Hua ate? Any ideas? Come on, she ate half of these remaining dumplings. She ate half of those. So what would be a good way to show that? Why don't we just draw another? Jason, go ahead, buddy.
6 times.
What we're doing is we're talking right now about how to represent with a picture that first Lynn ate half the dumplings, and then Hua ate half of the remaining dumplings. So really what we've got here is we've got half the dumplings have been eaten, and then another half were eaten by Hua. So we can almost color those in, and we can color in the blue one. And guys, now it says the last person named Wei ate the last 6 dumplings. So what should we write in this last part, this last rectangle? Go ahead, Stella. What should we write? If Wei ate the last 6 dumplings, what do you think we should write in this remaining part right here? Jason?
6.
Right. Everybody do that. So you know that this is Hua, and this was Lynn, and then this was Wei, and Wei ate the last 6 dumplings. So the big question now is how many were in the bowl before any were eaten? Now, if there were 6 here, what do you think Hugh ate and Lynn? Let's think about it. Wei had 6. Huey had, what did Huey have? Raise your hand if you know. Raise your hand. Catherine, I'm going to choose you. How many did Hugh eat? Hugh eat? Remember, doesn't her number look the same as Wei's? Because she ate a quarter. And so she ate 1/4. Wei ate 1/4. And Lynn ate a half. Stella, how many did Hua eat? Take a guess.
6.
Of course, because Wei ate a quarter and Hua ate a quarter, and they're both 6. Jason, how many did Lynn eat?
12.
Very, very good. Catherine, if we add those together, what do we get?
24.
Oh, that was awesome. There must have been 24 dumplings. So what if I told you that we had the same exact problem? And instead of 6 dumplings, Wei ate the last 10. Now remember, when the number was 6, we had a total of 24 dumplings. 6 plus 6 plus 12. Who could tell me what would happen if Wei ate the last 10 dumplings? Now, hi, Eleanor.
Hi.
So, sweetheart, draw a rectangle to represent all the dumplings. Draw a smaller rectangle to represent the 1/2 dumplings. Well, let's see. That's not going to be 1/2. I would say more like this would represent what Lynn ate. And then we have to represent what Hua ate. And who can do that? Because that would be another quarter. And then Wei ate 10. So here we had Hua, Lynn, Wei, and this was a quarter, this was a quarter, and this was a half. Now, everybody think about it. We're going to say it on 3. How many total dumplings were there? On 3. 1, 2, 3, go.
40.
Right. It equals 40. So you can answer this question any way you want. There are so many fun ways to ask this question, but I think representing dumplings with rectangles is the best way to approach that question. Okay, now let's go on to talking about snails. If it takes Swishy the snail 10 minutes to crawl 2 inches. Now, everybody write that down. It would be inches per minute. And you write that down as a fraction. Inches over minute. You could say IN that's an abbreviation, over MIN, which is an abbreviation. Now, who can tell me what this fraction is? You know that the snail can go 10 minutes and can go 2 inches. So what would the fraction, what that fraction is? Anyone want to take a shot? Come on, 10 minutes, 2 inches. Inches, minutes. What do you think, Jason?
2 hours.
Yes, right. Everybody look at this. Everybody, come on. It says 10 minutes. So if we do minutes on the bottom, we write it says 2 inches. So if we look at inches, we put 2 in the numerator. So we start with what's called a ratio. Everybody say the word ratio.
Ratio.
It's a very hard word because the T is not pronounced like a T. It's not pronounced ratio. It's pronounced ratio, almost as if the word had an SH in it, but it doesn't. It really is just ratio like this, RATIO. Now, the ratio of minutes to inches is 10 to 2, inches per minute of 2 to 10. Now, how many minutes will it take him to crawl 10 inches? So everybody draw an equal sign. We know that we want 10 inches. So where should I put the 10? In the numerator of the fraction or in the denominator of the fraction? Where do you think I should put the 10? Go ahead, Catherine.
On the top.
Yes, and that is called the numerator of the fraction. I'll write it down for you. Numerator. That's the top of a fraction. Now, on the bottom of the fraction, that's what we have to find out. Everybody write an X. X means, are you ready for this? It means I don't know. I don't know how many minutes it would take, but I do know that I need to find out. So if I'm looking at this fraction, how many of you can see the way we get from 2 to 10? How do we get from 2 to 10 with a ratio? We have to multiply it by what number, everybody? On 3. 1, 2, 3, go. Go ahead, Eleanor. Go ahead, Eleanor.
I is 10 on the top.
Yeah. Oh, but look at what we need. 2 times what number equals 10?
5. So then it's 5.
5. And therefore, 10 times 5 is going to be our answer. Don't say it out loud. Everybody write it down. In fact, you could even write X equals, and then the answer. On 3. 1, 2, 3, go.
50.
Right.
50.
Great, guys. Eleanor, do you see that? So we know that it's going to take this snail 50 to crawl 10 inches, 10 minutes to crawl 2 inches. How many minutes would it take to crawl 1 inch? How many minutes would it take the snail to crawl 1 inch? On 3, everybody. 1, 2, 3, go.
1. Over 5.
It's 1 over 5. It would take 5 minutes for the snail to go 1 inch, 10 minutes to go 2 inches, 50 minutes to go 10 inches. Now, who can tell me how many inches in 1 hour? Now, this is a little bit harder because Mr. Kramer changed it from minutes to hours. So it's a little bit different. Eleanor, what do you think?
30 minutes.
Well, we know that it's 1 hour. How many minutes are in 1 hour?
60.
Right. So we know that this is the same. It is the same thing as solving this question for 60 minutes. So what do you think the unknown, I'll call this unknown value y, how many inches do you think that the snail could go? Jason, what do you think?
12.
Right, because everyone, look at this. If the snail could go 5 minutes and 1 inch, 5 times what equals 60? And 5 times 60, I'm sorry, 5 times 12 equals 60. Therefore, you know that you've got to multiply 1 by 12. And that's going to give you 12 inches. So what's really fun about this is that the snail can go exactly 1 foot every 1 hour. So let me ask you a question. How many feet could the snail go in 1 day? So think about that. We know that the snail can go 1 foot in 1 hour. How far in feet could the snail travel in 1 day? Now, you may need to ask me a question, and that's okay. Is there some information you'd like to know? Stella, what do you think? I want to hear from you. If you don't know the answer, what would you like to know about hours and days? Anybody have a good question?
How many minutes in one day?
Ah, that's a great question. But are we looking for minutes here? Or are we looking for how many what are in a day?
Hours.
Hours. Raise your hand if you know how many hours are in 1 day. Okay, on 3. 1, 2, 3.
24.
Yes. So you could have said 24 hours. How many feet? Come on, guys. On 3. 1, 2, 3. Go.
24. 24.
That is exactly right. So we can go 24 feet in 1 day. Now, how many yards can we go in 1 day? So this is the snail, and you obviously need to ask a question here. How many feet are in 1 yard? Who knows that? If you can, go on, say it on 3. 1, 2, 3.
12.
No, there are 12 inches in 1 foot. But how many feet are in 1 yard? That's the question. Ah, everybody write that down. There are 3 feet in 1 yard. So if there are 24 feet for 1 day, how many yards is 24 feet? And the question you've got to be asking yourself is 3 times what number equals 24? And that is going to tell you how many yards the snail can travel in a day. The other way to think about it is 24 divided by 3, and that will give you the same answer. Now write it down. If you already know the answer, Jason, why don't you draw a picture of 3 feet per yard and making up 24 feet? Who thinks they know? I know Jason knows. How many people know how many yards are in 24 feet? On 3. 1, 2, 3. Stella, go.
8.
Ah, what'd you get, Catherine?
8.
And Jason?
8.
And Eleanor?
I don't know.
Well, Eleanor, do you know the math fact 3 times 8 equals 24? And if you don't know that, that's okay, because you could just think of drawing 8 dots, Eleanor. If you drew 8 dots, and then what you did was you drew another 2 rows, then you would have 8 times 3. It's called an array. And you could count by 8s. You could count by 3s. We could even count by 6s. Who wants to decide what to count by? Go ahead, Eleanor.
8.
Let's count by 8, everybody. Are you ready? Let's do it. 8.
8. 16. 24.
And there it is, guys. 8 times 3 equals 24. Therefore, 8 yards can be traveled in 1 day. Now, Stella asked a really interesting question. She said, and Stella, do you remember your question? How many what?
Minutes in a day.
Minutes are in 1 day. Now, the first thing we know is that there are how many hours in 1 day? On 3. 1, 2, 3, go.
24.
Now, Stella, I'm going to ask you this question. How many minutes are there in every hour? So in 1 hour, how many minutes? Go ahead, Stella.
60.
So everybody, we have to multiply to answer Stella's question. We have to multiply 24 times 60. Now, I want you guys to write that down. We're going to approach this kind of interestingly. We're going to write out 60 times 24, and we're going to rewrite both of them. Are you ready? So 60 is 6 times what number? Who knows what 60 is? 6 times what number? On 3. 1, 2, 3, go.
10.
Very
10.
good. So we can say 10 times 6 times 20 plus 4. I like to do something called partition my numbers. So I can write 24 as 20 plus 4. Now, the first thing I want to do is I want to distribute my 6 to 20 and then to 4. So if I said 6 times 20, how many of you can count by 20s with me? Raise your hand if you can count by 20s. Let's try it. Are you ready? Go. 20.
20, 40, 60, 80, 120.
Okay, stop right there. Stop right there. 6 of them. Let's count. 1, 2, 3, 4, 5, 6. Therefore, we now can write down the number 120, but then we have to add that to 6 times 4. Raise your hand if you know 6 times 4. And it's the same as 3 times 8, Eleanor. On 3. 1, 2, 3, go.
24.
And if we add 120 to 24 on 3, what do we get? 1, 2, 3.
144.
Now, I don't know if you remember, but this number has a special name. The name of this number, who knows the name of the number 144? Just like the number 12 is called a dozen. Jason, what is the number 144 called?
Where?
I can't really hear you. Can you speak up a little bit?
Square number.
Yeah. Oh, yes. It is called a square number. That means that if we multiply 12 times itself, we get 144. And do you know what else it's called? You guys are going to laugh. Are you ready? 144 is called a gross. And gross is actually an adjective in English that is not a very nice adjective. So let's say that you're wearing beautiful clothes and going to a party, and then you step in mud and you get mud all over your beautiful pants and shirt. You know what you might say? You might say, "Ooh, mommy, that was gross," because gross is an adjective that means something unpleasant. But guess what? The number 144 has nothing to do with something unpleasant. In fact, it's a noun, and it means a gross is simply 12 twelves or 12 dozen. Yes, Jason, do you have a question?
No.
Now, guys, we still have to multiply that to answer Stella's question. We've got to multiply 144 by what number, everybody? What did we forget?
10.
Right. So everybody, when you multiply 144 times 10, you simply write out the number 144. And after it, you tack on a what? For one place value.
10. 0.
A zero. All you have to do is tack on a zero. And Stella, that's the answer to your question. There are 1,440 minutes in one day. Now, there's a very strange thing that I'm going to tell you right now, okay? There is a musical, and I think it's a musical on Broadway. I'm not entirely sure. And the musical is called Rent. And in this musical, they sing a song called, I think it's called Minutes in a Year. And do you know how the song goes? Does anybody know? Now, the problem is that I can't sing very well, but would you like me to try a little bit?
Yeah.
Okay, here we go, guys. Are you ready? We know that there are 1,440 minutes in one day. In 1 year, there are, ready? 525,600 minutes. Everybody say it together. Ready? 525,600 minutes. How do you measure a year in a life? Isn't that cool? Now, I wish I knew the other words, but now, Stella, have you heard that song before?
I mean, I hear a song that has a kind of the same music as that. It's called like Seasons.
Wow, cool. That would be really cool. Now, guys, the way we know this, if we take 1,440 and we multiply it by the number of days in a year. So how many of you know how many days there are in 1 year? So there are how many days in 1 year? Okay, on 3. 1, 2, 3, go.
365.
Awesome. Great job. Now, guys, guess what? All we have to do is multiply 1,440 by 365. And what do we get? Would you like to sing it? Here we go. 1, 2, 3. 525,600 minutes. And that equals 1 year. Unbelievable. So now for us to do this mathematics, we're going to need to learn a lot more. How many of you would like to work hard so we can do multiplication like this? Wouldn't that be neat? Yes, I want to do it. I want to do it. Now, guys, there is so much fun we could have. What if we decided to say, how many seconds are there? How many seconds are there in a year? Would you guys like to know that?
Yes. Yeah.
Yes. Now, let's start counting. Are you ready? There are 31. Well, you know what? I'm not going to say the number. I'm going to write the number, and then you guys are going to say it with me. There are, and the way you write it is it's a 3-1 with a comma, a 5-3-6 with a comma, and 3 zeros. Now, I'm going to make this a little easier for you guys to see. Are you ready? We're going to say this number. Now, hold on a second. Are you ready? Think about what these numbers represent. Think about what these numbers represent. Okay, here we go. How many seconds in a year? Go.
1 million 536,000.
And that's it, guys. 31,536,000 seconds in 1 year. And it's so much fun to think that every year that we live, we get to pass through. And really, if you think about it, since our heart beats at about 60 beats per minute, we have about 31,536,000 heartbeats in a year. Stella, what were you going to say? I can't hear you, honey. You raised your hand, love. What were you going to say?
Really actually wanted to say something.
You say you did not? Okay, no worries, no worries. So, do you guys enjoy thinking about how many heartbeats you guys have in 1 year? In another lesson that we do together, we might actually try to figure out how many heartbeats we would have in a whole lifetime, which would be a lot of fun. Okay, are you guys ready? Albert has 120 cents in nickels and quarters. He has the same number of nickels and quarters. So if nickels are N and quarters are Q, what could you put in between this to represent nickels and quarters being the same number? What operation could you put there? On three, guys. 1, 2, 3, go.
Equal.
Everybody write that down. N equals Q. And it represents, it's called an algebraic. Everybody say the word. Algebraic. Algebraic representation of nickels and quarters, which are the same. Now, who could think of an algebraic representation for 120 cents in nickels and quarters? Now, before we do that, I'm going to write this out, okay? I'm going to write out 150 cents in pennies and dimes. So can we agree that we could call the number of pennies the letter P?
Yeah.
Could we call the number of dimes the letter D?
Yes. Yeah.
And who can tell me how many cents there are in 1 penny? On three. 1, 2, 3.
1 penny.
And what about 1 dime?
10. 10.
10 cents. Therefore, guys, we can give an algebraic representation of 1 times P. And we really just need to say P, but we'll say 1 times P plus 10 times D equals how many cents?
150.
Exactly. 150 cents. Okay, now, if we can write out an algebraic representation of P plus 10D equals 150, how could we write out an algebraic representation for nickels and quarters, which add up to 120 cents? Who thinks they can talk about that? Remember, we just did one where we had 150 cents, pennies and dimes. So how can we use that thinking? And I'll leave the problem up for you. Write it down. Think about how you could write the number of cents in a nickel plus the number of cents in a dime. I'm sorry, in a quarter. So the number of cents in a nickel plus the number of cents in a quarter equals how many total cents? What do you think? How many total cents, guys? Go ahead, say it.
125.
Right, 120 cents. Now, guys, how many cents is in 1 nickel? Go ahead, say it out loud.
5 times.
How many cents are in 1 nickel? Eleanor, how many cents are in 1 nickel? Eleanor, how many cents are in 1 nickel? Go ahead, Stella.
5.
That's right. Eleanor, I don't know if you can hear us. There are 5 cents in every nickel. Jason, how many cents are there in every quarter?
Okay. 5.
25 cents. So everybody, you can write down 5N plus 25Q equals, whoops, equals 120 cents. Now that is pretty cool. Now, the question is, how many quarters does he have? Now let's go back to a single page. And what we're going to do is we're going to think about what we've written down. We've written down two separate equations, two separate algebraic equations. 5N plus 25Q equals 120, and N equals N. What could we do to solve this, to find out the number of quarters? Think about it. So, Jason, do you have any ideas? And Jason, could you move your computer just a little bit, because you're kind of really low and you're kind of hiding behind your name. And if you look at your picture inside the computer and you see your whole face, then you know that I can see you too. Okay, Jason, now tell me what you think.
N equals 2.
So you think N equals 2?
2.
And what about quarters? How many quarters?
5.
5 quarters. Interesting. Now, guys, I like what he's saying, but aren't the number of nickels and quarters supposed to be the same? Everybody? So why don't we think about, Jason, we need to think about a number of nickels and a number of quarters that are the same. So here's what I'd like to propose. Let's take this equation and let's write it lower down. 5N plus 25Q equals 120. Now, we know that the nickels have to equal the quarters. Therefore, if I had, let's say I had 1 nickel and I had 1 quarter. Who can tell me what is 1 nickel is 5 cents, 1 quarter is 25 cents. How many total cents do I have? Come on, 25 plus 5 on 3. 1, 2, 3.
30.
That's right. I have 30 cents. Now, you know that 30 is not our answer. So let's move that answer down. Now let's try 5 cents for 2 nickels and 25 cents for 2 quarters. Now remember, 2 quarters is how much, everybody? On 3. 1, 2, 3. 50. And 50 plus 5 times 2 is?
10.
And therefore?
60.
And guys, 60 is not enough. The question I have for you is, does anybody have an idea of what the number is going to be? We know that 1 doesn't work. We know that 2 doesn't work. Throw out a number and let's test it. Eleanor, do you have any ideas? Catherine, I know Jason has an idea. Go ahead, Eleanor.
4.
We can only test it. We can only test it. I have no idea. Let's try it, everybody. 5 times 4 plus 25 times 4 equals 120. Now, everybody, if you can do 5 4 times, say it on 3. Go ahead, Stella. 1, 2, 3, go.
1, 2,
And what about 25? And what about 25 times 4? 4 25s, 4 quarters. On 3. 1, 2, 3, go.
100.
Everybody, is that our answer?
Yes.
Yes. Very, very nice.
Yes.
Eleanor and Jason, you got it. He has 4 quarters. And how many nickels? And how many nickels, guys? 4 quarters and? He has 4 quarters and what? How many nickels does he have?
4.
Right, he has 4 nickels as well. Now, what would happen if somebody had 5 pennies, 5 nickels, 5 dimes, and 5 quarters? How many cents do they have?
5 nickels.
By the way, guys, can you tell me how many cents are there in 1 penny? 1 penny, go. 1 penny, how many cents? On 3. 1, 2, 3, go. 1 cents in a nickel. Cents in a nickel. Go ahead. On 3. 1, 2, 3, go.
5.
Cents in a dime. 1, 2, 3, go.
10.
And cents in a quarter. 1, 2, 3, go.
25.
So we're going to create what's called a frequency chart. And the frequency chart shows that we have 5 of everything, and we're going to add them all up. So we're going to do the multiplication, and then we're going to add them. So we have 1 times 5 is what? Go.
5.
And Stella, you do the next one. 5 times 5 is what, Stella?
25.
Awesome. And Catherine, 10 times 5?
50.
50. And Jason, 25 times 5?
125.
Awesome. Now, Eleanor, lead us in the addition. How do we add 5 plus 25 plus 50 plus 125? What are we going to do first, honey?
9, 10, 50, 125.
Go ahead, Eleanor.
15.
15, that's right. And then we have to carry a 1 here. I don't know.
1.
And what do you get? Oh my gosh.
Oh my gosh.
I mean, just can you go on the computer? Have Michael help so we can get them tethered up. My God. Oh my God. Now, guys, are you ready? 1 second.
Yes.
So add 2 plus 5 plus 2 plus 1, guys. No. Give me 5 minutes.
5 minutes.
So 1 plus 2 plus 5 plus 2.
10.
That's right. And if we carry a 1, 1 plus 1 is what?
2.
And look at what we have, guys. How many dollars? Yeah.
205.
Oh my God. That is awesome. You guys are amazing. So here's what I'm going to do. I'm going to give you a problem to work on, and I'm going to go help somebody do something really quick, and I'll be right back with
You're talking bit by bit. It's like you're frozen.
Are you ready? Okay, I'm going to put myself on mute. You guys work on this, and I'll be right back with you. All right, be right back with Okay, I'm back with you guys. So you have Olivia's family has 5 children, right? Now, think about it. That's including Olivia. So how many brothers and sisters does Olivia have? Everybody say it on 3. 1, 2, 3, go. She's got 4 brothers and sisters. Now, their
4.
ages are 17, 16, 14, 9, and 7. Now, when she added the 4 siblings, she got 47. So which numbers would you have to add to get 47? Any ideas? Stella, what do you think? Were you not raising your hand, Stella? Were you just raising a lamp?
I'm just holding on to something.
Say again, honey.
I was just holding on to something.
Oh yeah, because it looks like you're raising your hand. Jason, what do you want to tell us, buddy? Okay, who's got an idea? Jason, are you speaking? Go ahead, buddy.
79. 14.
And you're saying that if we add up those numbers, it's going to be 14, 24, and that's going to be 25. Huh. I'm not so sure. Maybe not. Think about it. Who knows what 7 plus 9 plus 7 plus 4 is? Well, we know that 7 plus 9 is 16. And we know that 16 plus 4 is what?
20.
That's right. Michael, grab their boat. And that's 20. And 20 plus 7 is what?
27.
And guys, look how beautiful that is. So we know that Olivia must be how old?
47.
So therefore, she must be how many?
47.
She must be 16, guys, because her siblings are 17, 14, 9, and 7, because they added up to 47. And guys, that is what we needed to do. So Olivia's age is 16. Now, guys, next week, I want to hear all about what you did, and maybe you can sing that song to me. Remember that song? What was that song again? 525,600 minutes, right? How do you measure a day in a life? And so I will say to you this. Are you ready? I will see you guys in exactly 10,020 minutes. Say, I'll see you in 10,020 minutes. See you in 10,020. Bye, guys.
Bye. Bye.
Bye-bye.
Thank you.
Bye, you're welcome.